Have you ever wondered why, when you jump, you always come back down? Or why a ball you throw up eventually falls to the ground? It's not magic, it's a force. A fundamental, super important force called gravity. Think of it as the universe's invisible string, constantly pulling things together. It's the reason we're all stuck to this big, beautiful planet we call Earth. Without it, we'd just float away into space, along with our houses, our cars, and even the air we breathe. Gravity is the ultimate cosmic glue, holding everything in its proper place. It's a silent, unseen force that shapes our world in countless ways. Let's start with a classic example. An apple. Imagine you're sitting under an apple tree. Suddenly an apple detaches from its branch. It doesn't float up into the sky or drift sideways. It falls straight down, drawn toward the center of the earth. This simple observation is gravity in action. The Earth is incredibly massive, so its gravitational pull is very strong. It pulls on the apple and, believe it or not, the apple also pulls on the Earth. It's just that the Earth is so much bigger that the apple's pull is too tiny to notice. This pull is what gives the apple weight. This same force does more than just pull apples down. It shapes rivers, orbits, and everything in between. So, who figured all this stuff out? The story often starts with a brilliant scientist named Sir Isaac Newton. It's the 1600s. Newton relaxing in a garden, pondering the universe's big questions. As the tale goes, he saw an apple fall from a tree. This wasn't just any apple. It was the apple that sparked a revolutionary idea. He didn't just see a piece of fruit hitting the ground. He saw a profound connection between the earth and the objects on it. It was a moment of pure scientific insight, a classic aha moment that would forever change how we understand the universe. Newton started to wonder, if gravity can pull an apple, how far does that pull reach? Does it stop at the top of the tree? Does it reach the mountaintops? He looked up at the moon. What if the same force that pulled the apple to the ground was also pulling on the moon, keeping it in its orbit around the Earth? It was a mind-blowing concept for the time. He imagined the moon was constantly falling toward Earth, just like the apple. Think about it like this: if you throw a ball horizontally, gravity pulls it down and it lands some distance away. If you throw it faster, it travels farther before it hits the ground. Imagine you could throw the ball so incredibly fast. Newton didn't just stop with the idea, he put it into mathematical terms. This became known as Newton's law of universal gravitation. It sounds complicated, but the core idea is pretty simple. It can be broken down into two main parts. First, the force of gravity depends on mass. The more mass an object has, the stronger its gravitational pull. That's why the Earth, with its huge mass, has a much stronger pull than a tiny apple. Think of mass as the amount of stuff in an object. More stuff means more gravitational force. The second part of the law is about distance. The force of gravity gets weaker as the distance between two objects increases. It's like listening to music from a speaker. When you're standing right next to it, the sound is loud. As you walk away, the sound gets fainter and fainter. Gravity works in a similar way. The farther you get from the center of the Earth, the weaker its gravitational pull becomes. This is why astronauts in orbit feel weightless. They are still being pulled by Earth's gravity, but because they are farther away and moving very fast, they are in a constant state of freefall. So let's put it all together. The law states that every object in the universe attracts every other object. The strength of this attraction depends on two things: how much mass the objects have and how far apart they are. More mass means more force. More distance means less force. This applies to everything. The influence of gravity is absolutely everywhere, shaping our world on both small and grand scales. On Earth, it dictates the very structure of our environment. Gravity pulls water from the clouds as rain, which then gathers into streams, flows into rivers, and eventually makes its way to the ocean. It's the force that carves out canyons and valleys over millions of years. Even the air we breathe is held close to the Earth's surface by gravity. Without it, our planet would be as barren and airless as the moon. Think about life itself. Plants and trees have evolved to grow upwards, directly against the pull of gravity, to reach for sunlight. Their roots, on the other hand, grow downwards, anchored deep in the soil by that same force. Our own bodies are built to withstand Earth's gravity. Our bones and muscles are strong enough to support our weight and allow us to move around. When astronauts spend a long time in space, away from Earth's strong pull, they have to exercise constantly to prevent their bones and muscles from weakening. Gravity is the personal trainer we all have from the moment we are born, but gravity's reach extends far beyond our planet. It is the master architect of the cosmos. Gravity is the force that pulled together dust and gas clouds billions of years ago to form our sun and all the planets. It's what keeps the Earth at a perfect, life-sustaining distance from the sun, giving us our seasons and a stable climate. On the grandest scale, gravity weaves the cosmic web. It's easy to take gravity for granted because it's always there, a constant and invisible part of our lives. But without it, our world would be completely unrecognizable. Think about your morning routine. The water from your shower head falls down because of gravity. The coffee you pour fills your mug from the bottom up because of gravity. The very act of sitting in a chair walking down the street riding a bike, it keeps your feet firmly planted on the ground, providing the friction and stability needed for almost every action you take. Gravity is also essential for fun and recreation. When you play basketball, gravity is what brings the ball back down through the hoop. When you go skiing or snowboarding, you're using gravity to slide down a mountain. Roller coasters are thrilling because they are elaborate gravity-powered machines. Even a simple playground slide is a lesson in gravitational physics. Beyond our daily actions, gravity is critical for the technologies we depend on. The satellites that provide us with GPS navigation, weather forecasts, and global communications are all held in their precise orbits by a delicate balance with Earth's gravity. Hydroelectric dams generate clean energy by using the force of gravity on water stored in a reservoir. Even the systems that deliver water to our homes rely on gravity to create pressure and flow through pipes. So the next time you drop a pen, see rain falling outside your window, or look up at the moon in the night sky, take a moment to think about gravity. It's not just a topic in a science textbook, it's the force that holds your world together. It connects you to the ground beneath your feet, to the planets in our solar system, and to the most distant stars in the universe. It's a simple, elegant, and powerful force that makes everything possible. And that, I think, is pretty cool. Science is all around us. Remember, more mass equals sign more gravity. Further away equals sign weaker pull. And it applies everywhere, from pebbles to galaxies. It helps us launch satellites, predict orbits, and understand our universe. From building worlds to igniting stars, gravity organizes the cosmos into the breathtaking spectacle we see today. So next time you see an apple fall or the moon hang above you, remember there's an invisible force connecting everything. Gravity, the universe's invisible string. Science is everywhere. Keep wondering. If you enjoyed this, subscribe to learn more.